All right, in this video, I'm going to go over solving rational equations, which is kind of the same as my previous video, only now we've got variables in the denominators of fractions. But what's easy about this is that we're just going to use math rules to manipulate things to make it like we're just solving linear equations. Anyways, so really not learning anything new. We're just combining things that we've learned before in order to figure these out, right? We're just making things easier on ourselves, you know? So instead of trying to solve it like this, we're going to use the LCD, or the lowest common denominator, of all of these to get rid of all the fractions. That's brilliant. Because nobody likes fractions anyways, except for maybe me. So what is our lowest common denominator? First of all, you don't have to use the lowest common denominator. Any common denominator will do. That's the important part. But it is easier if you use the lowest one. And if you can find the lowest one, that's great. And sometimes teachers will emphasize the lowest common denominator and ask you for the lowest common denominator. They'll actually just throw a curveball at you on a test and just ask for the lowest common denominator and ask you not to even solve the equation. They just want the lowest common denominator because they want you to prove that you can find it. So what is the lowest common denominator? And it's between all three of these fractions. You know, it's not just these two fractions, it's all three of them. And if you were thinking 2x, you would be right. Now, why is 2x important? Why do we need that lowest common denominator? Well, we can, as we've been doing in solving equations, we can do certain things to both sides of the equation, right? You multiply one side by something, you got to multiply the other side by something, right? And so what we're thinking with the lowest common denominator is if we multiply this side by 2x over 1, it's not 2x over 2x like we do usually with trying to make fractions the same. We're just multiplying it by 2x. We realize that 2x divided by 2x cancels out, and we're just left with 7 on that side. That's what we're trying to do. We're trying to get rid of the denominators by using mathematical rules. So we don't mess it up, we got to multiply both sides by 2x. And putting the parentheses around it is important because we got to remember to distribute that. So 2x divided by x is just 2, and then we're multiplying that by 2, right? 2 times 2, 2x times 2. Instead of trying to do 2 steps at once, let me just put this. And just distribute the 2x over there, 2x times 2 over x, and then 2x times 3 over 2. And now cancel out the things that are being multiplied, because this is also multiplication, right? And because it's multiplication, we can do that multiplication or division however we want. So we can cancel out things because 2 divided by 2 is just 1. And x divided by x is just 1. So we're left with 2 times 2 and x times 3. All right, and we have that 7 over on the other side. Now it's a much easier equation to solve. Just by multiplying both sides of the equation by that lowest common denominator. So now what do? Subtract 4 from both sides. We want to get that x all by itself. So minus 4 is 3. Divide both sides by negative 3. And what do we get? That's a 1, right? Negative 3 divided by negative 3 is 1 times x, which is just x. 3 divided by negative 3 is negative 1. And there's your answer. Plug that back in. 2 over negative 1 is negative 2 minus 3 halves equals 7 over 2 times negative 1, which is just negative 2. Common denominator here. Negative 4 over 2 minus 3 over 2 is negative 7 over 2. That's a pretty bad handwriting, but yeah, negative 7 over 2 equals negative 7 over 2. Just check my answer there, just to make sure. Now, that is how you solve an equation where we have variables in the denominators. All right, I wanted to mention something important before I moved on to the next problem. There is something called excluded values. And it happens when you have variables in denominators. Now, what are excluded values? Well, we have to recognize that in math, we cannot divide by 0. That is undefined. Maybe someone's defined it by now, I don't know. But as of right now, in my knowledge, it's undefined. So the denominator cannot equal 0. Denominator, let me just write that over here. Denominator cannot equal 0. Denominator cannot equal 0. So x right here is just x cannot be 0. 2x cannot be 0. And we just kind of solve for x, just like a normal equation. We set that whole denominator equal to 0, but it's not equal to 0, so it can't equal to 0, so I put that slash through it. Now, some teachers might not like that you put the slash through it, but I do, because it can't equal 0. So our excluded value for this problem would be 0. So when we got our answer, it was x equals negative 1. The whole answer is x equals negative 1. Excluded values are 0. Excluded value is 0. And usually there's more than one excluded value. So that is the entire answer there. All right, now in this next problem, I added to the title here, state excluded values, because that is very important. Now, so first thing we're going to do is state the excluded values, because the excluded values are always based on the problem you start with. So x cannot be 0, right? Because that whole denominator is just x. This whole denominator cannot be 0, but it's got a -6 in there. So we need to solve for x just like we're solving for x in any normal equation, and add 6 to both sides of the equation, and we get x cannot be 6. So our excluded values are 0 and 6. And we just kind of note that on the side. Okay? 0 and 6 excluded. And now we solve it. Lowest common denominator. Usually, lowest common denominator is just multiplying that denominator by the other denominator, and that's what we have here. Or, you may have noticed, we have one fraction equal to another fraction, and some people are thinking, oh, we can cross multiply. You'd be right. You can cross multiply. You can multiply x times 3, get 3x, and multiply 5 times x minus 6. Just got to make sure you distribute. 5x minus 6. Now, what's the other way of doing that? That's kind of explains why cross multiplication works. Well, we had the lowest common denominator, right? Which was, I'm just going to rewrite the whole thing here. Lowest common denominator was x times x minus 6. Don't have to distribute that. That's what's nice about this part. The x minus 6 cancels out here on this side, and the x cancels out here on this side. So what are we left with? 5 times x minus 6 and x times 3. That's why cross cancellation works, because we multiplied both sides by the lowest common denominator. Just a little side note. So, now that we have everything nice in a linear form, we can get that x by itself. Subtract 5x from both sides. That becomes 0, right? So we get -6 is left. 3 minus 5 is -2. Don't forget the x. One last step. Almost wrote -3 there. I don't know why. Divide both sides by -2. Negative divided by a negative is a positive. 6 divided by 2 is 3. Is that one of our excluded values? No. So that's our answer. 0 and 6 excluded is also part of the answer. But all right, here's our next problem. Sometimes you may have to factor in order to find the lowest common denominator. Can this factor? No. Can this factor? No. This one, absolutely. How do we factor that? Well, we have to think of something that adds to get -1, right? And multiplies to get -2. So what multiplies to get -2? Well, -1 and 2. But -1 plus 2 is 1. That's not it. So not that one. -2 and 1. It's our only option, really. -2 plus 1 is -1. So that works. So we're going to use -2 and +1. That factors into x minus 2 and x plus 1. Oh, gee. That worked out nicely, because that is exactly what we have over here. And the things that all three of these have in common are those two binomials. So let's rewrite this whole thing. 1 over x minus 2 times x plus 1 equals 1 over x plus 1 plus 2 over x minus 2. All right. Multiply everything by the lowest common denominator. So multiply this whole thing by x minus 2 times x plus 1. Don't have to FOIL it all out, don't have to distributive property it all out, because we know it's going to cancel out. I love canceling things out. X minus 2 times x plus 1. Now, same thing over here, but we are going to kind of distribute. We're going to distribute both of these numbers to both of these numbers inside the parentheses, right? So we're going to multiply both of these by 2 times x minus 2. So x minus 2, I'm just going to write out the whole thing so there's no confusion. I'm going to put parentheses around it. That helps me think that way because it's still a binomial, right? Same here. X minus 2 times x plus 1 times 1 over x plus 1. Since all these are being multiplied together, we can pick and choose which ones we want to divide. So x minus 2 and x minus 2 cancel out. X plus 1 and x plus 1 cancel out. So when you divide something by itself, you get 1. 3 million divided by 3 million is 1. X minus 2 divided by x minus 2 is 1. So all we have left is this 2 times x plus 1, which needs to be distributed. Same here, 1 times x minus 2, which when you distribute a 1, nothing changes. So that was easy. Here, don't forget the other side of the equation. We divided x minus 2 divided by x minus 2, and we divided x plus 1 divided by x plus 1. So it all canceled out, and all we have left is 1. That was easy. Easy math. All right, now all we got to do is solve for x, get x by itself. So, but we got to distribute this first. 2x plus 2 plus x minus 2, x, that was awful, x minus 2 equals 1. Combine like terms. We got x's here, and we've got non-x's here. 2x plus 1x is 3x. 2 minus 2 is 0. So that just leaves us with 3x equals 1. Divide both sides by 3. Running out of room here. X equals 1 over 3. Whoa, wait a minute. I forgot something very important. Excluded values. Excluded values. What are they? Well, x minus 2 cannot be 0. So we add 2 to both sides there. X cannot be 2. So excluded value 2. And x plus 1. And we decided, we factored this out and we realized it was the same as these. So we only need to do it twice. X plus 1 cannot be 0. Subtract 1 from both sides, and x cannot be negative 1. sometimes you forget those excluded values. Well, whether you do them at the beginning or at the end, gotta remember them. Excluded values. So, is 2 or negative 1 1/3? No, so we're good. All right, one more problem just for extra practice. Can these factor? No, can't factor them. Can we solve for our excluded values? Sure, 2x plus 1 cannot equal 0. Three x plus 1 cannot equal 0. So the excluded values are -2, -1/2, and -1/3. Okay. Well, now we gotta solve it. Well, what's our lowest common denominator? Just multiply this denominator by that denominator. Or one fraction equal to another fraction, we can cross multiply. So just take this, multiply it by that. And take this and multiply it by that, and there's your little cross. All right, and distribute. Don't forget to distribute. -3 times 3x, -9x. -3 times 1 is -3 equals, don't forget the equal sign, 4 times 2x, which is 8x. 4 times 1, which is 4. Now it's easy from here on out, right? Minus 8x from both sides. -17x. Yeah, -3 equals 4. Add 3 to both sides. -17x equals 7. Divide both sides by -17. Is that the same as -1/3 or -1/2? Nope. Can we divide 17 by 7? I wish no. We cannot.